All right, in this question, we're looking for hybridization. What is the hybridization of the central atom? Now, remember, we can have multiple central atoms, but in this case, we just have one central atom, that Br. So if we have some sort of carbon-based molecule, we could look at the hybridization of each central atom. But here we're just focusing on the first one. And already we can see it's an exception because we have 5 fluorines being bonded to that Br. And remember, if we have a atom that is below this, or in or below this third period, it can have more than an octet around it. And so that's what we're looking at here. But again, we still have to go through this process of counting valence electrons, filling an octet, and then adding extra ones to the central atom, or do we have to go through the process of finding double bonds or triple bonds if we don't have enough electrons to just make single bonds? So we're going to start out by drawing the Lewis structure. First thing we do is count the valence electrons. Now, Br is our central atom, but we're going to go 7. We have our 7 plus 5 times 7, which is 35. So that gives us 42 valence electrons. Okay, let's move this down a little bit. I'm going to put my fluorines around. I'm going to draw a bond. We always start with single bonds. Now, fluorines, they like that single bond. They are not in the third period, so they cannot have an expanded octet. And so now we will count out. We have 8, 16, 24, 32, 40. So that's 40, and there are 42 to use. So we're going to put even another one on the central atom. So that central atom has 6 electron groups. Remember, first we count electron groups. We have 5 bonds plus a lone pair, so 6 electron groups. Now, how does hybridization work? It's based off the electron geometry. Here we have 6 electron groups, right? So we can have 2, 3, 4, 5, 6. So here we have sp, here we have sp2, sp3, sp3d, sp3d2, based on the electron groups and the electron geometry, right? This would be linear, we got tetrahedral, so on. So those line up every time. So to find hybridization, you find the electron geometry, and then you know the hybridization. So let's put that in. So we have sp3d2. There we go. So remember, this is telling us, so there's 1 s orbital being hybridized. There are 3 p orbitals, and there are 2 d orbitals. So we look at s, we have the 3p, and then we have the 5d, and we're hybridizing all of those to be equivalent in energy. And then we have the rest of the D's up there. Now we could do, if we have sp, we're just looking at s and p's, and we're only hybridizing 2 of them. So we would have the sp down here, and then we'd have more p's up here. So review hybridization, and then align it with electron geometry.